No fishing rods, no modern tackle, no commercial equipment. Across the vast waterways of North America, Native American tribes faced a fundamental challenge: extract enough protein from rivers, lakes, and streams to sustain entire communities through harsh winters and seasonal food shortages. Fish represented the difference between survival and starvation, but catching them required techniques that could work in all weather conditions, all seasons, and all water types, using only materials found in nature. They needed fishing methods that could capture large quantities of fish efficiently without depleting local populations. They needed techniques that could work in frozen rivers, turbulent rapids, and deep lakes where conventional methods failed. They needed systems that could be constructed and operated by entire communities, from children to elders, maximizing food production while minimizing individual risk. Every technique mattered. One failed fishing season, one broken weir, one miscalculated migration timing, and an entire tribe could face starvation during the long winter months when other food sources were scarce. The difference between abundance and famine often came down to fishing knowledge that had been perfected over thousands of years. The Native American tribes, who thrived in diverse aquatic environments, had developed fishing techniques that were more sophisticated and productive than modern commercial methods. Systems that could harvest fish sustainably while maintaining ecological balance and ensuring long-term food security. But which forgotten fishing techniques enabled Native Americans to capture massive quantities of fish using only natural materials and traditional knowledge? How did they construct fish traps and weirs that could operate automatically for weeks without maintenance? What seasonal timing and migration knowledge allowed them to predict and intercept fish movements with incredible accuracy? And how did they develop preservation and processing methods that could store fish protein for months without refrigeration? Today, we're exploring the ingenious fishing techniques that sustained Native American civilizations for millennia, methods that proved more effective and sustainable than many modern fishing technologies. My name is Sam, and this is Wild America. For over 10,000 years, Native American tribes developed sophisticated fishing systems that could sustainably harvest aquatic resources while maintaining ecological balance. These weren't simple fishing methods. They were complex technological systems that integrated engineering, ecology, and community organization to create reliable food production systems. 1. The Fish Weir Engineering System. The Fish Weir system represented the pinnacle of Native American aquatic engineering, creating permanent installations that could automatically capture fish during migration periods while allowing sustainable population management through selective harvesting techniques. Fish weirs were sophisticated engineering structures that used water flow dynamics, fish behavior, and strategic positioning to create highly effective fish capture systems. Weir construction required understanding hydraulic engineering, fish biology, and structural design that could withstand seasonal flooding and ice damage. These installations could operate continuously for months with minimal maintenance while capturing thousands of fish during peak migration periods. Native American tribes constructed weirs using carefully selected stones, wooden stakes, and woven brush barriers that could redirect fish movement while withstanding water pressure and seasonal flooding. Construction techniques included foundation stabilization using large anchor stones placed in precise patterns to resist water flow forces. Barrier anchoring involved driving wooden stakes deep into riverbed sediments and securing them with stone weights and interwoven brush materials. Flow management required understanding water hydraulics to create funnel effects that guided fish into capture areas while maintaining structural integrity during high water periods. The selective harvesting systems enabled sustainable fish management through controlled capture that maintained breeding populations while maximizing food production. Native American weir operators used selective harvesting techniques that captured mature fish while allowing juveniles and breeding stock to pass through, ensuring sustainable population management. Selective techniques included mesh sizing calculations that allowed small fish to escape while retaining mature specimens. Barrier spacing was precisely calculated to create openings that permitted juvenile fish passage while blocking adult fish movement. Timing control involved opening and closing capture areas according to fish life cycle stages and population assessment data. Native American communities operated weirs according to seasonal fish migration patterns, adjusting capture intensity and maintenance schedules to maximize harvest during peak periods while allowing population recovery during spawning seasons. Operation management included timing coordination based on environmental indicators such as water temperature, flow rates, and seasonal changes that triggered fish migration behavior. Maintenance procedures involved regular inspection of structural components, replacement of damaged materials, and adjustment of barrier positions to maintain optimal capture efficiency. Harvest distribution systems ensured equitable resource allocation among community members while maintaining sufficient breeding stock for population sustainability. Native American tribes organized Weir operations through coordinated labor systems that included construction crews, maintenance teams, and harvest distribution networks that ensured equitable resource access and effective installation management. Community organization included specialized work crews with specific responsibilities for different aspects of Weir operation. Construction crews handled initial installation and major repairs using traditional engineering knowledge passed down through generations. Maintenance teams performed regular upkeep and minor repairs to ensure continuous operation throughout fishing seasons. Harvest distribution networks managed fish collection, processing, and allocation according to community needs and traditional sharing protocols. The engineering sophistication of Native American fish weirs rivaled modern commercial fishing installations in their effectiveness and sustainability. These systems could capture tons of fish during migration periods while maintaining fish populations for future generations through careful management and selective harvesting practices. 2. The underwater fish drive system. The underwater fish drive system used coordinated human activity to herd fish into capture areas, combining swimming skills, breath control, and tactical coordination to create highly effective fish harvesting operations in deep water environments. Fish drive operations required exceptional swimming abilities, breath control, and underwater coordination that enabled teams of swimmers to herd fish into nets, traps, or shallow areas where they could be captured efficiently. Drive techniques included underwater movement patterns that exploited fish behavior responses to human presence. Fish herding involved understanding fish psychology and group behavior to predict movement patterns and guide fish toward capture areas. Coordination methods required sophisticated communication systems that functioned effectively in aquatic environments where verbal communication was impossible. Native American tribes trained specialized swimmers through rigorous conditioning programs that developed exceptional breath control, underwater endurance, and fish herding skills necessary for effective drive operations. Training programs began in childhood with progressive swimming instruction that built aquatic confidence and technical skills. Breath control exercises included underwater meditation techniques that extended breath-holding capacity to several minutes. Underwater navigation training developed spatial awareness and directional control in three-dimensional aquatic environments. Fish behavior study involved observing fish response patterns to human movement and developing herding techniques that exploited natural fish instincts. Native American drive teams used sophisticated coordination techniques, including underwater signals, positioning strategies, and tactical movements that enabled effective fish herding despite communication limitations in aquatic environments. Coordination techniques included hand signal systems that conveyed complex tactical information underwater. Positioning protocols established swimmer locations and movement patterns that created effective fish herding formations. Movement patterns were choreographed to create pressure waves and visual stimuli that influenced fish behavior and guided them toward capture areas. Team coordination required precise timing and spatial awareness to maintain formation integrity while adapting to changing fish behavior patterns. Native American swimmers used fish herding techniques that exploited natural fish behavior patterns, water currents, and environmental features to guide fish toward nets, traps, or shallow areas where they could be captured efficiently. Herding techniques included noise generation through underwater percussion that created acoustic pressure waves to influence fish movement. Visual intimidation involved coordinated swimmer movements that created threatening visual patterns that triggered fish flight responses. Current manipulation used understanding of water flow dynamics to position swimmers where their movements would be amplified by natural water currents, increasing their herding effectiveness. Native American drive operations included comprehensive safety systems with buddy partnerships, emergency response procedures, and risk management protocols that protected swimmers during dangerous underwater operations. Safety systems included hazard assessment protocols that evaluated water conditions, underwater obstacles, and environmental risks before beginning drive operations. Emergency procedures established rescue protocols for swimmers in distress, including surface support teams and emergency extraction methods. Protective measures included pre-dive conditioning, equipment checks, and communication systems that maintained contact between underwater teams and surface coordinators. The underwater fish drive system represented one of the most physically demanding and technically sophisticated fishing methods developed by Native Americans, requiring exceptional human performance and coordination to achieve success in challenging aquatic environments. 3. The ice fishing spear system. The ice fishing spear system enabled year-round fish harvesting through specialized techniques that could penetrate frozen water surfaces and capture fish in winter conditions when other food sources were unavailable. Ice fishing operations required specialized equipment, techniques, and knowledge that enabled effective fish capture through frozen water surfaces during winter months, when fish represented critical protein sources. Ice techniques included hole-cutting methods that created fishing access through ice layers up to several feet thick. Spear construction involved creating precision instruments capable of accurate underwater targeting and effective fish penetration. Fish location methods required understanding winter fish behavior patterns and underwater habitat preferences that enabled effective targeting during ice fishing operations. Native American tribes constructed fishing spears using carefully shaped points, balanced shafts, and specialized designs that enabled accurate underwater targeting and effective fish penetration. Spear construction began with point creation using sharpened bone, antler, or stone materials that could penetrate fish effectively while maintaining structural integrity. Point sharpening techniques included grinding and honing methods that created razor-sharp edges capable of clean fish penetration. Shaft balancing involved selecting wood materials with appropriate weight distribution and flexibility characteristics that enabled accurate throwing and effective underwater performance. Grip preparation included handle wrapping and surface texturing that provided secure control during wet, cold conditions. Native American ice fishers used specialized cutting tools and techniques to create and maintain fishing holes through ice surfaces, including hole sizing, edge management, and safety procedures that enabled effective winter fishing operations. Ice cutting tools included bone and stone implements designed specifically for ice penetration and hole enlargement. Cutting techniques involved systematic ice removal methods that created holes of optimal size for spearfishing while minimizing energy expenditure. Hole maintenance included regular ice removal to prevent refreezing and edge smoothing to facilitate spear entry and fish extraction. Safety procedures included ice thickness testing and hole positioning to avoid dangerous ice conditions. Native American ice fishers developed expertise in locating winter fish concentrations through understanding of underwater topography, fish behavior patterns, and seasonal habitat preferences that enabled effective targeting during ice fishing operations. Location techniques included depth assessment using weighted lines and probes to map underwater terrain and identify fish habitat areas. Habitat analysis involved understanding fish preferences for specific underwater features such as drop-offs, vegetation beds, and current areas where fish concentrated during winter months. Behavior prediction required knowledge of fish activity patterns, feeding schedules, and movement cycles that enabled optimal timing for ice fishing operations. Native American ice fishers developed exceptional patience and timing skills that enabled them to wait for optimal fishing conditions and fish activity periods that maximized capture success during limited winter fishing opportunities. Timing techniques included behavior observation that identified fish activity patterns and feeding cycles. Pattern recognition involved understanding environmental indicators that predicted fish movement and feeding behavior. Condition assessment included evaluating weather patterns, water temperature changes, and seasonal factors that influenced fish activity levels and fishing success rates. The ice fishing spear system required exceptional skill, patience, and environmental knowledge that enabled Native American communities to maintain protein sources throughout harsh winter months when other food procurement methods were impossible. 4. The poison fish stunning system. The poison fish stunning system used natural plant toxins to temporarily stun fish in confined water areas, enabling mass capture without permanent environmental damage or fish population depletion. Fish stunning operations utilized carefully selected plant materials that contain natural toxins capable of temporarily incapacitating fish without causing permanent harm to aquatic ecosystems. Stunning techniques included plant selection based on toxin content, preparation methods that concentrated active compounds, and application procedures that ensured effective fish stunning while maintaining environmental safety. The system required extensive botanical knowledge and precise application techniques to achieve mass fish capture while preserving aquatic ecosystem integrity. Native American tribes used specific plants, including derris root, buckeye nuts, and other natural materials that contained compounds capable of temporarily stunning fish without causing permanent harm to aquatic environments. Plant preparation included grinding techniques that broke down plant materials to release active compounds. Extraction methods involved water-based processes that concentrated toxins while removing inactive plant materials. Concentration techniques included evaporation and filtration processes that created potent stunning agents from raw plant materials. Storage methods preserved prepared toxins for extended periods while maintaining their effectiveness. Native American fish stunners used sophisticated application techniques that ensured even toxin distribution in dammed or confined water areas, creating temporary stunning effects that enabled mass fish collection while allowing rapid ecosystem recovery. Application techniques included distribution patterns that ensured uniform toxin concentration throughout target water areas. Concentration management involved calculating optimal toxin levels that achieved fish stunning without causing permanent harm to aquatic life. Timing control required understanding toxin action periods and fish recovery rates to maximize capture opportunities while ensuring fish survival after collection. Native American tribes constructed temporary dams, diversions, and containment systems that isolated water sections for stunning operations while preventing toxin spread to larger aquatic systems and enabling rapid ecosystem recovery. Containment construction included dam building using stones, logs, and brush materials that created temporary water barriers. Water diversion techniques redirected stream flow to isolate specific water sections for stunning operations. Isolation techniques prevented toxin spread to larger water bodies while maintaining controlled environments for fish, stunning, and collection operations. Native American stunning operations included comprehensive recovery procedures that neutralized toxins, restored water flow, and enabled rapid ecosystem recovery following fish collection, ensuring long-term environmental sustainability and continued resource availability. Recovery techniques included toxin neutralization using natural compounds that rendered stunning agents harmless to aquatic life. Water management involved restoring natural flow patterns and removing temporary barriers after fish collection. Habitat restoration included replacing disturbed materials and ensuring aquatic environments returned to natural conditions after stunning operations. The poison fish stunning system demonstrated sophisticated understanding of plant chemistry, aquatic ecology, and environmental management that enabled mass fish harvest while maintaining long-term ecosystem sustainability. 5. The night torch fishing system. The night torch fishing system exploited fish behavior patterns and light attraction to enable highly effective fishing during darkness when fish were most active and vulnerable to capture. Night fishing operations utilized artificial light sources to attract and disorient fish during darkness, creating opportunities for mass capture using nets, spears, and other fishing implements. Night techniques included light construction using natural materials that provided bright, sustained illumination. Fish attraction methods exploited natural fish responses to artificial light sources. Capture methods maximized fishing success during optimal nighttime conditions when fish behavior patterns favored mass harvesting operations. Native American night fishers constructed torches using pine pitch, birch bark, and other natural materials that provided bright, long-lasting illumination for fish attraction while remaining waterproof and manageable during aquatic operations. Torch construction began with fuel preparation involving collection and processing of resinous materials that burned brightly and resisted water damage. Fuel materials included pine pitch extraction, birch bark preparation, and other combustible substances that provided sustained burning. Wick creation involved preparing fibrous materials that controlled burning rates and flame characteristics. Waterproofing techniques included protective coatings and construction methods that maintained torch functionality in wet conditions. Native American night fishers understood that artificial light attracted and disoriented many fish species, creating opportunities for easy capture using nets, spears, and other implements when fish congregated around light sources. Attraction techniques included light positioning strategies that maximized fish response while enabling effective capture operations. Intensity control involved managing flame size and brightness to optimize fish attraction without creating excessive glare that interfered with fishing operations. Timing management required understanding fish activity patterns and optimal lighting periods that maximized capture opportunities during nighttime fishing operations. Native American night fishing teams used sophisticated coordination techniques that enabled effective teamwork during darkness while managing the risks associated with open flames, water operations, and limited visibility conditions. Coordination techniques included communication protocols that functioned effectively in low-light conditions with background noise from water and fire. Positioning strategies established team member locations that maximized fishing effectiveness while maintaining safety during dangerous nighttime operations. Safety procedures included fire management protocols, water safety measures, and emergency response systems that protected team members during high-risk nighttime fishing operations. Native American night fishing operations included efficient capture and processing systems that maximized fish collection during optimal conditions while ensuring proper handling and preservation of captured fish for immediate consumption or storage. Processing techniques included capture methods that efficiently collected attracted fish using nets, spears, and other implements. Handling procedures ensured captured fish remained fresh and undamaged during collection and processing operations. Preservation techniques included immediate processing methods that prepared fish for consumption or storage while maintaining nutritional value and preventing spoilage. The night torch fishing system required exceptional coordination, safety management, and technical skill that enabled Native American communities to exploit nighttime fish behavior patterns for highly effective mass harvesting operations. 6. The Seasonal Migration Interception System. The Seasonal Migration Interception System utilized detailed knowledge of fish migration patterns, timing, and routes to position capture systems at optimal locations during peak fish movement periods. Migration interception required comprehensive understanding of fish behavior patterns, seasonal timing, and environmental factors that influenced fish movement, enabling strategic positioning of capture systems for maximum effectiveness. Interception systems included timing analysis that predicted optimal fishing periods based on environmental indicators. Route identification involved mapping fish movement patterns and identifying strategic interception locations. Positioning strategies maximized capture opportunities while minimizing resource investment and labor requirements. Native American tribes developed detailed knowledge of fish migration patterns, including timing, routes, and environmental triggers that enabled them to predict and intercept fish movements with remarkable accuracy across different seasons and water conditions. Pattern analysis included environmental observation that identified migration triggers such as water temperature changes, seasonal weather patterns, and food availability cycles. Timing documentation involved recording migration schedules and correlating them with environmental indicators to develop predictive models. Route mapping included identifying fish movement corridors, bottlenecks, and concentration areas that provided optimal interception opportunities. Native American fishing teams positioned nets, traps, and other capture equipment at strategic locations along known migration routes, including river narrows, shallow areas, and natural bottlenecks where fish could be intercepted most effectively. Positioning strategies included site analysis that evaluated water flow patterns, fish behavior characteristics, and environmental features that influenced capture effectiveness. Equipment optimization involved selecting and positioning capture devices to maximize fish interception while minimizing escape opportunities. Route control included temporary barriers and diversions that channeled fish movement toward capture areas and increased interception success rates. Native American migration specialists monitored environmental conditions, including water temperature, flow rates, weather patterns, and food availability that influenced fish migration timing, enabling accurate prediction of optimal interception opportunities. Environmental monitoring included condition observation that tracked environmental indicators and correlated them with fish behavior patterns. Pattern recognition involved identifying environmental changes that triggered migration behavior and predicted fish movement timing. Timing prediction required understanding complex relationships between environmental factors and fish behavior that enabled accurate forecasting of optimal fishing periods. Native American tribes coordinated entire communities during major fish migrations, organizing equipment deployment, labor allocation, and harvest distribution to maximize capture success, while ensuring equitable resource access among tribal members. Community coordination included planning procedures that organized community resources and labor for maximum fishing effectiveness. Work organization involved assigning specific roles and responsibilities to community members based on skills, experience, and physical capabilities. Resource distribution included harvest allocation systems that ensured equitable access to captured fish while maintaining community cohesion and cooperation. The seasonal migration interception system represented sophisticated ecological knowledge and community organization that enabled Native American tribes to exploit predictable fish behavior patterns for highly effective mass harvesting operations. 7. The underwater fish trap construction system. The underwater fish trap construction system created permanent or semi-permanent capture installations that could operate automatically in submerged environments, providing continuous fish harvesting with minimal maintenance requirements. Underwater trap construction required specialized techniques that could create effective fish capture systems in submerged environments while withstanding water pressure, current forces, and environmental conditions. Trap construction included design principles that exploited fish behavior patterns and water flow dynamics. Material selection involved choosing natural materials that could withstand underwater conditions while maintaining structural integrity. Installation techniques created secure, effective underwater installations that operated automatically for extended periods. Native American trap builders designed underwater installations that exploited natural fish behavior patterns, water currents, and structural principles to create self-operating capture systems that could function effectively for extended periods with minimal maintenance. Trap design included behavioral analysis that identified fish movement patterns and behavioral responses that could be exploited for capture purposes. Flow utilization involved understanding water current patterns and designing trap configurations that used natural water flow to guide fish into capture areas. Structural optimization included engineering principles that created stable, effective trap installations using traditional materials and construction techniques. Native American trap constructors used carefully selected materials including stone, wood, and woven elements that could withstand underwater conditions while maintaining structural integrity and capture effectiveness over extended periods. Construction techniques included material preparation methods that treated natural materials for underwater durability and effectiveness. Assembly methods involved construction procedures that created secure, stable trap installations using traditional joining and fastening techniques. Installation procedures included positioning and anchoring methods that secured traps in optimal locations while ensuring structural stability under varying environmental conditions. Native American trap installers used sophisticated anchoring and positioning techniques that secured underwater traps in optimal locations while ensuring structural stability under varying water levels, current forces, and environmental conditions. Installation techniques included anchoring methods that secured trap installations to underwater terrain using stone weights, wooden stakes, and other natural anchoring systems. Positioning strategies involved selecting optimal trap locations based on fish behavior patterns, water flow characteristics, and environmental features that maximized capture effectiveness. Stability management included engineering techniques that ensured trap installations remained secure and functional under varying water conditions and environmental stresses. Native American trap operators developed comprehensive maintenance systems that included regular inspection, cleaning, repair, and optimization procedures that ensured continued trap effectiveness and maximum fish capture over extended operational periods. Maintenance techniques included inspection protocols that assessed trap condition and identified maintenance needs. Repair methods involved restoration procedures that maintained trap functionality and structural integrity. Performance optimization included adjustment and modification techniques that improved trap effectiveness based on operational experience and changing environmental conditions. The underwater fish trap construction system demonstrated sophisticated engineering knowledge and construction skills that enabled Native American communities to create automated fishing systems that provided continuous fish harvesting with minimal labor investment. "The fish were our brothers who gave their lives so we could live," recalled Ojibwe elder Joseph Kingbird in 1923. Our ancestors understood that taking fish was a sacred responsibility that required knowledge, respect, and wisdom passed down through countless generations. Every technique, every trap, every method was designed not just to catch fish, but to ensure that fish would always be there for our children and their children. The techniques we've explored demonstrate that Native American fishing systems were more than survival methods. They were sophisticated technologies that sustained civilizations for thousands of years while maintaining ecological balance. Modern fisheries management continues to learn from these traditional techniques, proving that indigenous knowledge offers solutions to contemporary resource management challenges. My name is Sam, and this is Wild America,